Welcome to 5 AI engineering patterns from a Sitecore Content SDK migration analyzer. This isn't a talk about migrating from JSS to the Content SDK, but it is where I started my journey with this. And the main takeaway that I hope you get from this is a set of engineering patterns that I certainly learned while building a repeatable code-base analysis engine. Quick note on me, I'm Nick Allen. I'm the technical director of ThinkFresh Digital. Next year, I will have my 20-year Sitecore anniversary, which is kind of cool, but strange at the same time. And prompted by the previous talk, I did a computer science degree in 1998, so I was one of those people building websites in the 90s. So this talk is about something I try to make useful for myself, but also for multiple clients and projects. And I'll be around for the conference, so feel free to come and have a conversation or find me on the usual channels and Slack and so on. So what is this talk about? So today there are many one-shot ways to get useful code migration help. So I'm certainly not arguing against that approach. I see many anecdotes in the community about being able to migrate very quickly from JSS to the Content SDK using all sorts of techniques, but mostly probably involving Claude Code and perhaps Google Chrome MCP servers and so on. But it is about patterns that I learned while building for repeatability and in enterprise environments. And I hope that you will take away from today also that these patterns extend beyond Sitecore. So why was this problem worth solving in the first place? So XM Cloud, as we knew it back then, back last year, was moving towards the Content SDK. And with the SitecoreAI effectively today mandates that because JSS 23 will not support SitecoreAI and JSS 22 reaches end of life in June. So if you haven't already, time to start thinking about it. And the official migration guide that we got initially covers most of the changes. It's well written, it's updated frequently, but not every customization and not every scenario or every pathway is covered by the official documentation. And if you go all the way back to May, June last year, foundational models would have no idea what you're talking about if you ask them about the Sitecore Content SDK. And so the migration problem existed, but it's not uniform. And also, teams don't particularly want to spend program velocity doing front-end upgrades as much as we as developers enjoy them, perhaps. It's not so easy to extol the benefits of such a thing in a program of work. And so this started really back in April 2025, ironically at SUGCON in Antwerp. And right after that conference, I took part in a 2-day AI hackathon based in Oxford, which is where I live. One of the benefits of living in Oxford is there's no shortage of students doing AI hackathons. So I joined a hackathon where we were sponsored by 11 Labs, and we did work with LangChain to build a voice experience where it had nothing to do with Sitecore. It was to do with using technology to solve a crisis of isolation and loneliness in our communities using AI, which I thought at the time was slightly odd, seeing as AI is potentially the cause of some of those problems. But there you go. And so I took some of that knowledge to do a presentation in Budapest in June on exploring the Content SDK. I'd been doing some research into it and what it meant for developers and how the architecture was different to JSS. And for a bit of fun, I used some of those skills that I built at that hackathon to build a voice experience app where I basically spoke to it and asked it to go out to GitHub and fetch my JSS-based repositories using the GitHub MCP server behind the scenes. And then basically tell me what I need to do to migrate that code base from JSS to the Content SDK. And it was all through the use of my voice, which was fun, but somewhat theoretical still at the time, and very much based on a single problem. So then the conversation changed a little bit, or the question at least changed a little bit after that. What if we were to take that a little bit more seriously and build a tool that would be able to take any JSS-based solution and migrate it to the Content SDK, um, regardless of complexity, whether it's a monorepo with multiple apps or a single app or whatever the case is, and to basically take that problem away with the usage of AI. And that meant that the assistant approach effectively changed into a CLI tool that a developer could use on their machine, point it at the repository, analyze the repository, and away you go. So I went from assistant demo to analysis engine. And one of the things that I wanted to do was I wanted per file findings. I wanted citations from the documentation to understand why things were happening. I wanted to analyze file by file, and then I wanted an aggregation to happen at the end of that to produce artifacts that could be used by non-technical teams and technical teams. So if you're in a regulated environment where you can't use AI to do automatic migrations, at least you have a project plan and file by file analysis for technical teams. Um, or if you're free to use AI tools, a mock down, essentially a prompt giving you the full plan for how to migrate your solution that you could hand off to people more technical to just get on with the job. What I kind of didn't realize we were building at the time was essentially plan mode when plan mode didn't yet exist in Cursor and VS Code and so on. And so at a high level, it ended up looking like this. So on the top left, you use a CLI tool to scan your repository, and then everything else sits inside of Azure using mostly Azure AI Foundry and a set of services. So the CLI queues up all of the files for analysis. The workers do the analysis job. They fetch context related to each file based from a knowledge base, which is essentially an Azure AI search vector database with official documentation loaded into it, plus some custom documentation that we'd written around that um, based on some work that we'd previously done doing manual migrations to the Content SDK back then. And based on the contents of that file and all of the information fetched from the knowledge base, putting those two things together, building a prompt around that, calling an LLM, and storing the findings, or at least the recommendations for how to migrate that file into a table, which can then be all picked up at the end of the job by an aggregator, which then produces the final um, artifacts. So just taking a step back, the migration problem got us thinking. The end architecture turned it into something usable. The 5 patterns that I'll talk about today made it reliable. And I believe those patterns transfer beyond the initial use case. So from this part on, I'm not really going to talk much about Sitecore, but um, I think as more and more of us start to work on Sitecore AI, I think much more of our work is going to transition to things like marketplace apps or building agentic agents. And so hopefully some of these patterns will trigger some thinking around building those types of things in Sitecore. So pattern one, RAG and smart chunking. I'm sure there are probably many of you in here that understand this problem well. But essentially, the code in isolation is not enough by itself to make a recommendation. We need the right documentation to go with it in order to understand how to migrate that code from one place to another. As I mentioned, that knowledge base is a combination of official documentation and custom documentation. And one of the first challenges is about how to actually chunk up that documentation and store it into a vector store. So LLMs and embedding models do have finite context windows. Um, the world is changing a lot. So now I think you can use Opus in max mode and have like 1 million token context windows. You probably could load an entire code base into that if you wanted to. But this is the process. This is the journey that we went through. And so um, when producing migration documentation, Christian Hahn pointed me in the direction of Chakra UI, who put quite good migration advice into their LLMs.txt. And the way they structure it is they essentially give you before and after code blocks. And so we took some inspiration from that and modified our um, knowledge base to be based on that type of format. So providing context about the problem and then sort of providing before and after examples of what the code should look like after a migration. So when splitting this information, you need to be slightly careful because you don't want to lose the meaning of the documentation during that chunking process. And you will need to chunk it up because of that, the context window problem. Then on the retrieval side, we used a hybrid search approach. So we wanted to support what we had called different products for this scenario. And by product, I mean, are you migrating JSS to JSS, JSS to Content SDK, or Content SDK to Content SDK, different pathways, different versions? And so we wanted to make sure that when we're retrieving relevant documentation from the knowledge base, that we're pre-filtering based on the current scenario that we are running. And so, first of all, the hybrid search will filter the documentation to only retrieve information that's relevant to our use case, and then perform that semantic search afterwards to get the right documentation relevant for the current file being analyzed. And the goal really here is to bind the right evidence to the right file. Our knowledge base repository looks like this. So we've structured it in terms of all the different migration scenarios that you might want to consider. And then each markdown file within that knowledge base has the metadata at the top using the front matter style that's commonly used in YAML. And then, as I say, the context and then sort of before and after instructions of how to handle that particular file. And this looks a little bit like this in practice. So I'm just running a very simple migration at the top left, just for a single file, just for demo purposes. So we're going to do a JSS to Content SDK migration. Select a source version, in this case 22.8. And then we'll just go for 1.0 just to show the process. When we run that, the job starts, and the first thing that happens when the file analyzer triggers is it will fetch the context related to this file from the knowledge base. So in this case, we've got all of the query text is the contents of the file, along with that metadata that we can use to do pre-filtering on the information that we're pulling back. And then as that runs through, it will turn the contents of that file into its embedding form. So we're comparing embeddings to embeddings to get that semantic match between what's in the documentation and what's in the file that we're migrating. That filter that we get is then translated into a filter that Azure Search will recognize. So there's things in here about scope. So is it documentation that applies to a specific file or not? And then the end result is we get a set of documents from the knowledge base that could be from a official source or a custom source, along with scores, rankings, and the actual documentation for that particular migration scenario. So moving on, once we were satisfied that we were able to successfully retrieve the right documentation that was relevant for the particular file that we were analyzing, and then we can take those file contents plus that documentation, embed that into the prompt that we're sending to the LLM, and then ask for essentially migration advice coming back. The next thing we wanted to deal with was the structured output from the LLM. So in a situation like this, where we're going file by file and then aggregating at the end, we don't really want the LLM to be returning prose. We don't want paragraphs of text back. We need a contract. We don't want to have a conversation at this point. We just want to know exactly what we need to do. And so we want every LLM invocation to return strict JSON. And that JSON schema includes an array of findings for that particular file. It includes the LLM's confidence level that the advice that it's providing is sound. It will provide citations from the documentation so we can link that back to the knowledge base to understand why that recommendation is being made, um, what the actions are for that particular file that we're migrating, and some indication of effort around that. So this works well for models that support, well, it works well for most models, but some models are easier to work with in the sense that they support structured output natively. And so we use the LangChain library just to abstract away some of that interaction with the underlying models. And if you're working with a model that supports structured output, you can simply provide it with the schema that you want the output to be in, and you'll get that back. You don't have to pass it out yourself. You don't need to check that the model actually returned JSON. All of that gets handled by LangChain, but not all models do support that natively. And so for those, even if you are within your prompts, telling the model that you want back a response in a certain format, sometimes the models will drift and you'll get back something that could, for example, be wrapped in code fences or include additional bits that you don't want in there, if you have to pass that JSON response after the fact. So again, what that looks like in practice, the same simple demo of a single file going through the system. And the first thing we do is we check whether the model type supports structured output. So the CLI tool allows you to specify, do I want GPT? Do I want DeepSeek? Do I want Claude? And so we know what model is being used. And it's just a very simple function that says, based on what model type's been selected, do we know if it supports structured output or not? And if it doesn't, we know we need to pass that response ourselves, but we also want to give the model a chance. So it might get it wrong the first time, and we might try a couple of times to force it to return a response in the format that we want, so we can pass it out into the schema that we need. So there's a little retry logic in here, and then there's bits in there around stripping out code fences, but eventually we get a clean output that we can pass into JSON and include that in our set of findings that we're putting into our findings table. And this will run through. And then what I'll show next after this particular run has completed is I'll do exactly the same thing with GPT, which is a model that we know supports structured output with LangChain. And you'll see that all of this code to do this after the fact parsing and validation kind of goes away. So that's just returned back those reports that I mentioned at the beginning. And we'll just run through that same process again. And this time, a much simpler invocation. We provide the schema that we want the response to adhere to, but we also say we want the raw output to be returned to us as well, because there's additional metadata in there that we might need, and we'll see that a bit in the next pattern. And so that handles validation, and yeah, it's a much simpler process. Okay, pattern 3, ASIC orchestration. So clearly, if we're taking a bunch of files in a code base and sending them all for analysis, we can't just run a parallel asynchronous call and just throw all that in an LLM and expect it to, or at least not a hosted model, and expect it to just go through gracefully. There are limits to throughput, and so the system needs back pressure, which is defined as how the system protects itself when the work arrives faster than it can be processed. So clearly, with a repository that might have hundreds or thousands of files, it's very easy to queue those up. but we do have a dependency on that model to return responses. Hosted models do have rate limits, and so we need retries. LangChain and other SDKs like the Vercel AI SDK handle a lot of this for you quite well at the single file level, but we need general system resilience around this. So things like idempotency and some jobs, some tasks will just fail regardless. And there's nothing, it's just one of those edge cases. So we don't want the system to jam up because of that. So just handling things like dead letter queues is kind of essential for a system like this. And so the pipeline naturally became queue driven. Looking at choices for this, I went with Azure Storage Queues because it was just simpler to work with at the time, and it was the smallest step from what we already had. So we were just playing around at the start, throwing a bunch of calls at the LLM. A lot of that retry with back-off logic was sitting inside of the CLI tool itself that was collecting all the files and sending them for analysis. But that clearly wasn't going to scale. And so the thing for us that was going to be the simplest to move away from that and put that logic into the back-end service was to move to queues. And then the life cycle of the CLI process essentially became initialize the job, queue up all the files for analysis, then poll to see what the status of the job is. And when the job has finished, call an endpoint to finalize the job and get the results or the aggregated results. And that does work well. We haven't had any problems with it. If I was to revisit this, I would look at durable functions instead, simply because it natively implements a fan in, fan out pattern or fan out, fan in. So fan out essentially takes one parent job, splits it into parallel child tasks, and then the fan in pattern will wait for all of those tasks to finish and then run the next step once afterwards, which fits very neatly onto the type of work we're doing here. Um, so yeah, dispatching end file jobs, wait for everything to finish, and then auto finalize. And that would take some of that job lifecycle responsibility away from the CLI, and the CLI becomes even simpler. Um, so I'll probably implement that at some point, but for the purpose, the storage queues are also working fine. So again, quick demo. Um, Same, just a single file being put through the system. We've got one function up here called jobs in queue. So you'll see the first thing that happens when that file gets submitted for analysis is it hits the queue function, which will just basically take the contents of the file, the metadata associated with the file, and put that onto the queue. And then the second function, the file analyzer, switched away from being an HTTP trigger to being a storage queue triggered function. So that basically monitors that queue and starts processing the information on the queue as soon as it becomes ready. Um, so there really wasn't many changes that had to be made at all to this side of things. Pattern 4, model routing. So if you think about a file analyzer, it's going to go through a repository, and all of the files in that repository will look different. And so initially we kind of baked in model choice into the CLI runner. So again, do I want to use DeepSeek? Do I want to use GPT or initially Claude wasn't available because we were working within Azure AI Foundry, but you can also now, as of a couple of months ago, I think, use Claude in Azure as well. Um, and kind of just walking back a little bit there. So w- building a system like this, I've seen a couple of ways of approaching it. I think some people will go for a premium model first and try and build the best possible outcome, and then try and pare back the cost of the model until it gets unacceptable. Um, or you could start with the cheapest model just to get going, see how far you get, and then see if upgrading the model produces better results. If you feel like there's not much more you can do from a code or prompting perspective. We were sending quite a lot of calls to LLMs, so I went with the latter. We started off with a cheaper model, and then once we had the system working end to end, started to scale up the models to see what effects that would have on the outcomes. But then we got to a point of this realization that because of the variability within files in a code base, picking a single model to handle that job is probably not the best way to approach things. And so we switched over to using or at least providing the model router as an option instead. The model router is very easy to work with in Azure. Essentially, it's like provisioning any other model, except when you provision the model, you get a couple of options in terms of configuration. So, do you want the model to route by, in terms of prioritizing quality of the outcome? Which obviously is going to be more expensive. Do you want to prioritize cost, or do you want to balance the two things? Um, if you are able to remove the job of a code-based migration into a process like this, I'd probably argue that cost isn't a huge factor, because obviously you're reducing costs on people having to do this work manually. But in any case, we configured it for a balanced approach. And the other thing you get with that is lower latency, because you could be routing to models that are designed for low latency and efficiency. And so as a result, your overall system performance improves a little bit as well. Um, I have found, and I don't know if it's just because of my subscription, but currently I can only provision the model router in East US2 or Sweden Central. Um, I did a little bit of digging into this, and apparently the Sweden Central thing is because Sweden Central has the strictest GDPR rules in the EEA. I don't know if that's 100% true, but that's one of the reasons that I've seen cited. Um, and the key thing here as well is that models are changing frequently. So if you're using something like Azure AI Foundry, there's going to be new models introduced all of the time, and our workflow around those models probably changes slower. And so we're keeping the model choice largely out of the application code. And as new models are introduced, we get the benefit of those without really having to do anything. So in this demo, I'm going to throw a few more files. This is kind of like a stock JSS install with something like 30 odd additional components added on top. So it's basically going to chug through that. This is sped up slightly, but the whole process is happening. It's retrieving the context from the knowledge base, putting that together with the file contents, sending that off to the LLM, and then model routers picking that up and bringing back that structured response. And then I sped up the video a little bit too much. So at the end, what's going to happen is a report gets opened in the browser, and you'll see in the report that we're also tracing the model choice back to the reporting. So if we want to understand when using the model router why a recommendation was made for a particular file, we can see which model was used to make that choice if we want to kind of look back and troubleshoot that or figure out why things might not be working as we expected. So if you've got very keen eyes, you'll be able to see it. There you go. That's that. So you may have seen in the report that the model choice is included. If you couldn't see it, you just have to trust me. And finally, automated evals. So without evals, every prompt tweak and every model swap is kind of guesswork. Obviously, you test the system, but when you throw that at an actual production workload, um, you're not there to supervise the model when it's returning recommendations. You can look at the kind of net result at the end, but what happened inside for every single evaluation or every single model invocation is a little bit harder to assess. And because of that, um, AI can change quite silently underneath you. And so, how do you identify regression if you're tweaking your prompts, tweaking your model choices? How do you know if in net outcome whether you have improved the system or regressed the system? And so evals, I've heard them described as unit tests for LLMs, sort of, I would say. Um, Unit tests are much more deterministic. So quite often a unit test is pass fail. You get back a Boolean. Whereas evals, account for the probabilistic nature of models, um, and therefore tend to be more in a range of completeness. So on a score of 1 to 5, did this particular model do what we wanted it to do, or produce um, an accurate response? So in a way, they're like unit tests, but not entirely. They gravitate around golden sets. So a golden set is a fixed collection of representative inputs with known expected outcomes. Um, this is quite a manual task. So depending on what you're doing, I think these can be very worth it to protect your system, but do expect human input into this. It's not something, I mean, you can use models to try and generate your golden sets in the first place, but you could, if you do that, end up in a kind of cyclical validation loop where you've got models telling you what your golden sets are, and then models running against the system. And so you'd kind of, you know, you need that human in the loop part to say, yes, that's a desired outcome, or no, that's a desired outcome, and exactly why. So there's a bit of time that goes into this, but it can pay off for critical workloads. So with a golden set, you're essentially saying, um, based on a specific task, here's an input, here's some documentation retrieved from a RAG process, if applicable, and here's what we kind of think the outcome should be. Now, the automated piece from this name comes from the fact that you've actually got a model that's running these evals. So you've got models assessing the work of other models. It's not that necessarily you can just throw these things at your application and get some one magic sort of automated test harnesses. Um, but yes, so essentially you're framing the problem, you're giving it an input, you're telling it what a good outcome looks like, and then you're having other models judge whether or not that was achieved. And that judgment essentially happens in evaluators. So you have all sorts of evaluators for different reasons. Azure will give you a set of general purpose evaluators, but for domain correctness, you will probably end up writing your own evaluators to measure correctness. So for example, Azure will give you lots of evaluators that focus around safety. But if you're running a code analysis engine, um, I wouldn't expect there to be any concerns about violent responses or anything like that. So um, you feel free to not include some of the evaluators that Azure will recommend out of the box. Um, and because of the kind of handheld nature of this, I would say start with things that are a little bit more deterministic. Now, you're not giving absolute truth. Again, we're in a probabilistic world here, not a deterministic world. And so if you start with something, in this use case, if we start with something more deterministic, like migrating a package.json file, where there are certain truths that we know exist in there, we know there are certain scripts that need to be modified, we know certain dependencies need to be changed. And regardless of the use case, that was probably true. And so things like that are more deterministic, and you can use that as a starting point just to kind of figure out what good starts to look like. Now, I don't recommend trying to run evaluators for every single file, because obviously that would not scale, but you may have custom evaluators for components in this use case, or evaluators for middleware, evaluators for plugins. Um, and then there's a couple of ways of running these things. So you can run them in the Azure portal. Um, I do that to figure out what good looks like, but ultimately you want to probably embed that into your CI/CD pipelines somewhere, so that you're actually protecting the code base a bit more proactively. So an example from the portal, if I create an evaluation, you can evaluate agents models, but I'm looking at data sets here, which are the golden sets that I referred to. So if I load up an example inside of here, you've got the query. So what are we doing? Plus some metadata, the input code, the response, a static response from RAG. So again, we're just doing a one-off um, sample here. And then we're mapping some of our golden set data to the fields that Azure's standard evaluators understand. So in this case, we want the input code to be provided as the context. And then you get all of the kind of standard evaluators. But for this use case, you kind of got just pick the ones that actually make sense. I wouldn't go for all of them, well, depending on what you're doing. But um, so here I'm just kind of removing the ones that are not applicable, but you can create your own evaluators in the portal as well. So effectively an evaluator is a prompt, really, underneath the hood, um, that's looking for a specific pattern, but they can return either Boolean responses or range responses from 1 to 5 of correctness. Um, so in here, I built an evaluator that cares specifically about what happens to a package JSON file during a migration of this type. So then you can review your setup and then run that. So again, this is very manual, um, and that's fine for figuring out, as I say, what good looks like. And you'll want to test to make sure that you get failures when you're supposed to, and so on. But once you progress past this, you probably want to integrate this into your CI/CD. So this is just one I have that runs every morning, and it does do a live call to an LLM. So it'll take essentially the same evaluator concept from the portal. There are libraries that Azure provides that you can mock the kind of evaluator environment. Um, they are better supported in Python, so that's what this is written in. And in the code base, there is essentially a GitHub action that installs all the necessary dependencies and is loaded with things like static representations of what a RAG pipeline may have returned for a specific file type. Um, then the prompt for the custom prompt for the evaluator. So so all of that will kind of get put together. It will do a live call to the LLM with the input that we've provided. We'll get a response back from the LLM, and then the evaluator will be called by the process to basically give us a score on how did we do in terms of what we expect. Um, I do believe it is possible to take the data that you get from this and upload it into the portal if you want to see it in there visually. I haven't gotten that far with it yet. So, but you do get an artifact at the end of this pipeline run, which contains things like obviously the results of the evaluation. So if you wanted to visualize that in some other way, you could push that somewhere else. But essentially, this will just keep running. So every time you are, changing your models or modifying your prompts, these will kind of flag when things are um, perhaps not going the way you want them to. However, it doesn't. I don't think it removes human review, um, but it is, I suppose, that canary in the mine. So the 5 patterns, what do they add up to? So RAG grounds the analysis, structured output makes it composable, async orchestration makes it operational at scale, routing makes it adaptable, and the evals make it governable. You may be thinking, could you take the output of this and just hand it off to something and have it do the migration? Absolutely, of course you can. So this is the code base that I ran through previously, which is a stock JSS build with something like 30 odd components added on top. I ran the job for this, took a couple of minutes, gave me back an MD file with instructions for an agent to go ahead and do the migration. This has been heavily sped up, but by the end of it, I think it says something like 20 minutes or something like that. Come on, not sped up enough. There you go, done. 22 minutes and 13 seconds. So what upgrade? you know, so if this is kind of the point, we started off building what is effectively a kind of a plan mode. But we kind of landed in a place where the output of that could be passed to an agent to go and automate the migration as well. For this, use case. So my takeaways from all of this is obviously calling models now is very easy. But coordinating a reliable workflow around it takes a little bit more consideration. We are working with probabilistic systems, not deterministic systems. So failure needs to be understood and accounted for, but it's not quite the same failure that we may be used to. And the goal really is repeatable behavior within defined boundaries, which are testable. Um, this is Parkinson's law, which basically says work is a function of the time available to us. Um, you could look at this in a negative sense and say, well, it doesn't matter if AI is making us more efficient because I'm still working 8-hour day and I'll just get given more work from somewhere else. You could look at it in a positive light as well, which is if my work is fixed, then I would rather spend less of my time doing things that aren't as valuable as some other things that I could be doing. And so these types of tools, I think you could ask the question, uh, are they making work quicker for us? But I think probably the better question is, um, did we build a safer, more repeatable way to do valuable work so we can focus our time on other things? And thank you for your time. I'll leave you with that. We have 3 minutes for questions if there are any questions.
Talking of time, that seems like an awful lot of work. Any idea how long you spent roughly?
Um, it's not as much work as it looks. It's I see it less as a did I spend too much time doing this when there are much simpler ways to solve that problem? And if you were to ask that question now, yes, there are much simpler ways to solve that specific problem. Um, which is kind of why at the start I sort of asserted that I'm not arguing that every code migration needs a custom AI solution. Certainly not. Um, for me, this was a way of learning AI engineering principles for a use case that was real, that had value attached to it. Um, I couldn't tell you exactly how much time I spent on it, but it's not as much as it perhaps looks like. Um, but the cool thing is you start off in one direction, you start to figure out what doesn't work, what works, you build on top of that. And then, at the end of that, it's a good way to learn, I think. Yeah. Rather than, it's so easy to take AI tools now and just throw them at problems and solve. But a lot of the times, sometimes you kind of feel like you're not really learning anything. And so those tools will come, those tools will go. There'll be new tools next week. But underneath all of that are the principles which I think hopefully stand the test of time a little bit more.
Yeah. Thank you. All right, thanks everyone. I think we have to stop here, and if you have some questions, I think you can ask Nick directly. Thank you.
Thank you.